So we've got Rena Leone, who's flown over from Boston, Massachusetts, not Lincolnshire. And Hugh, who's from London, and I'm from Cambridge. Okay, so I'm Director of Data Operations at Imply. Imply is like Confluent for Druid. We like to think so anyway. And I've been with them for 5 years, so I was there when there were like 20 of us. And I got really hideously drunk off our first kickoff, and it was really the bad thing to do. But anyway, okay, so Imply is all about this. So our customers are BI type people. They are people who are setting up dashboards, people who are running regular reports, people who are creating visualizations and embedding it on their websites. Basically, that's what our customers are doing. And the reason why we're here today is because of the importance commercially, as well as an open source to us, of people who are putting real-time data into the system that we provide.
No more alcohol.
No more alcohol for me. It might just be sugar. So it means like on the monitoring side, it means that people are able to look at their KPIs with a greater refresh, right? It's got better, more fresh data in it, more regularly provided data. On the alerting side, when we're working with network operations centers or telecoms people, it means that the alerts that they're creating in our software are actually triggered faster with more relevant data than if they were just batch uploading overnight, yawn. When it comes to visualizations, it means that if they've got this like embedded thing on their website, it might be something internal. So a company in Scotland, I keep forgetting which use cases are public and which ones aren't, so apologize. A company in Scotland, where they've got this like internal dashboarding tool, those visualizations, that data is, the visual isn't cached somewhere overnight and generated. It's immediate. When you generate that visual, it doesn't go and optimize the query somewhere on a Hadoop cluster and then execute it. It's doing it in real time. And when it comes to exploration, this is quite an interesting one. So I can say this, NTT Data in the US, they've got this exploratory tool that we sell, which is amazing, called Pivot. But it's got a sort of similar thing to like Superset, that kind of tooling where you can just drill into it and do exploration on the data. They're actually using that internally with their like BI tools, BI teams conversing with the end users, designing the thing and then embedding that into the dashboard. But what's critical to that about the real-time stuff is that it's relevant immediately to the end user, right? It makes sense to them straight away. They're looking at today's data and going, oh yeah, that makes sense to me today. Or if you're a branch manager and you want to look at today's figures, it just makes a whole more sense. Am I like rambling a bit? Makes sense, right? Real time really matters to all analytics use cases, right? So this is our UI. I show this because actually I did a meta study like a while ago of different characteristics of like UIs that get built with Druid with Kafka behind it. And they are all like the kind of thing I was going to say like my mum would use, but she wouldn't. But like, you know, you're dragging and dropping the thing. The schema's flexible. Like the aggregates aren't fixed by an ETL pipeline. They're just executing whatever you throw at it. It's real-time data that's coming in at this end. You know, you're able to see the stats immediately. They're very social experiences. People are sharing the URLs with one another. It's like, for those of us who've been around for a while, if I said like it's data democratization in action, can I get a yeah? Or like it's a true unlock for knowledge ecosystems. But it is like a very social experience. It's very relevant. It's very flexible. Blah de blah de blah. That's what all of these UIs with Druid and Kafka Kinesis are like, right? So in this beautiful diagram. The world in which Druid built up was one that already had event ecosystems. So we're kind of thinking like 10, 11 years ago, longer, 11, 12 years ago, when Kafka was, shall I say, on its way up. It wasn't like everybody was like, oh my God, I need to adopt Kafka, which is what it is like now. So this ecosystem has grown to include things like Flink and KSQL and other stream processors are available. But very early on, it had this relationship with Druid because the use case was necessary. And the use case was ad tech. And this is like in lots and lots of use cases internationally where Kafka becomes a really important delivery mechanism into Druid. So it means that we can consume events directly from the stream into Druid and make them queryable immediately. In terms of actually executing the queries, it's a SQL API or a JDBC API provided by Avatica. So you can plug in Superset, grew up at the same time. Thanks, Airbnb. Thank you, Maximin. But Tableau, look at anything can query at that side. And it fulfills a lot of functions that kind of are a bit of a gray area because we do have people who will use Druid for like a row-wise transformation or for pre-aggregating, but you wouldn't kind of do any complex AI with it. But it's just consuming from the stream. You can do batch ingestion in it, little bit of transformation. It does data optimization for you. It does a little bit like a serving database would, in that I can have both historical and real-time data queryable at the same source. And yeah, it's just a good database built for streaming OLAP. And it has been for a very long time. Am I selling this really well, Hugh? Excellent. Okay, so what Hugh is actually going to show you is some of the key bits of functionality. So I'm going to run through them all so you kind of get a sense of where Hugh is going in his presentation. So in terms of this native integration between the Kafka and Druid projects, the streaming ingestion is just consumers. There's nothing special. You just give the consumers the broker and the consumer properties and it goes and gets them. It doesn't use consumer groups. Actually, it has something else internal. So if you look at it and go, where's the consumer groups? Then you can ask us what they are alternatively. It has this level of transformation and filtering that can happen. Again, this is row-wise. So maybe one of the reasons I do that is because I'm dealing with ad tech data and I'm only interested in conversions. So at ingestion time, I set up my filter and I say, filter out anything that doesn't match these criteria. And I might have one table for conversions and one table for impressions, let's say. But as I mentioned, you might do that upstream. You might do aggregations. You might pre-aggregate stuff. Again, you can do that at ingestion time. It has inbuilt support for Apache data sketches. Anybody familiar or not familiar with Apache data sketches? All of them. Are you familiar? Okay, cool. Okay, so Apache Data Sketch is awesome for count distinct operations and quantile estimation and approximate distribution. I've forgotten what they all are. But anyway, really good for approximation. Very, very small representations of very high cardinality data sets. And we're talking like kilobytes. They're amazing things. If you don't know what they are, go and look at them. So we can generate those up front at ingestion time. So the next job that Druid can do for like OLAP use cases is to optimize the data for OLAP. Now you might find people are doing this in data lakes anyway and creating their Parquet files. Druid has something similar. It's just called the segment format, but it's columnarized, it's indexed, it's dictionary encoded, inverted indexes for those of us who used to work with Oracle. It partitions it. It's basically doing a lot of optimization automatically. And what you end up with is these tiny little files called segment files. And they're essentially like little databases. And because they're little databases, they are self-describing. So as the data's coming in, this schema can change, but the schema inside each file keeps track of that change. So you can change the data that's coming into your stream, which is very common when product owners go, oh, I'm bored, let's change everything. And the table actually materializes the schema. It's quite weird, because if you go into Druid, there's no create table command. It's actually realized by the ingestion. So it's cool, but it is a bit of a weird thing if all you're used to is, like me, SQL Server. So schema evolution, and you connect to schema registries, et cetera, as well. Then some people invent this really horrible thing called late arriving data and out of order data. Bastards. So because it's built for streaming, that can play havoc with partitioning schemes, especially in Druid where the primary partitioning scheme is time. So you could end up with these tiny, tiny little files that represent the 3 milliseconds that someone's SIM card woke up. So we have a process called compaction. It's improving all the time. There's some big things happening in compaction so that it basically, nobody knows it's even doing it. And its job is to basically defrag the database to keep it nice and orderly for parallelized execution, which is how you get to the stuff. So there's actually 2 different ways of querying data in Druid. Because I can accumulate 5 years worth of data rather than just 7 days, I can't think of a system that only holds data for 7 days. Because you can accumulate it, it means that you can then, you need to have a way of executing not just on the consumers, but also on this older data very quickly. So the way that Druid does that is it have this mechanism, first of all, which is going to pre-fetch the data to a dedicated process called the historical. So as the data is coming in, it's pre-fetching that data to the historical process on local disk, actually. And then it's using mmap and a ton of other caching mechanisms to make that query execution fast. As well as, specifically, I can say this to an audience like this, a scatter-gather or fan-out, fan-in, i.e. like MapReduce, execution method. So it's very good for very, very fast query patterns and query execution. But of course, you do have to resource all of that query execution to make that data hot all the time, and that can be not so good. Not all query patterns are the same, not all users are the same. Some users are more demanding than others. Some data isn't as important as others. And especially I found that like in streaming use cases, the older it gets, the less bothered they are. Whereas in finance, they want to go, yes, but what happened in 1914? Our retention period is infinite, is it? Great. So we have another mechanism which is called, it's actually internally called MSQ, multi-stage query engine. Essentially what it has is a different query execution pattern. This has got a shuffle stage between the processes. It doesn't have this kind of pyramidic kind of execution pattern. And that unlocks several things. If you've used Druid before version 24, which is maybe 18 months ago, 2 years ago, 18 months ago, this is brand new, right? So I used to live in this land, but now this is the new bit. And it means that you can do queries that have very weird joins. I worked on a use case in Clickstream, for example, where they're trying to do funnel analysis, where the query was like 1,000 lines. Well, if you put a query that's 1,000 lines long through this kind of execution method, it's going to go, no. Whereas with this one, it's much more like what we all grew up with, like a proper like SQL on Hadoop engine, a proper separation of storage and compute. It can do a lot more stuff, and that's quite new in Druid. So if I've got these mechanisms, query on arrival, I've got this mechanism, I've got optimization, I've got this OLAP optimized data format, as someone who's just joined at the back, who happens to be my boss, told me earlier, whose name's Gabriel, wave everybody, there are use cases where, for example, you want to use this kind of database to have not just your real-time data, but also historical data as well. Not just for cost saving, but just because it gives you a single point of entry to both of these things. So surprise, the other thing you can do in Druid is obviously just use batch ingestion. So you can batch ingest from S3, Google Cloud Storage, Azure Blob Storage, HTTP, web sources, and local files. Yeah, that's it. You can do into the same table, or you can replace, and that's how the updates work in Druid as well. So that, bringing us back to this diagram again, what that means is that Druid is this like self-contained unit. It's a little bit like a serving layer because we can have historical and live data together. It's a bit like a data warehouse because we can do group buys really quickly. It's a bit like a data lake because it stores this optimized copy of data which we can query asynchronously. It's a bit like a distributed query engine because we have this highly parallelized query execution pattern going on that's optimized for lots of different things. So it's a bit of a mishmash of databases. When somebody says to me, like, where does Druid fit? It's like this bringing together of lots of things we've learned over the last 10, 15, 20 years to build something specifically that's brilliant for streaming, right? It's like that's the world it lives in. So in terms of our customers, it means if they want to accumulate data over a long period of time and do group by queries, we can do that using Druid. If we've got customers who want to batch and stream at the same time, or maybe they are still in batch land because they work for a British company and no one's thought about real-time analytics yet, then you're slowly migrating them into that analytics process by making the batches smaller and smaller and smaller. And eventually they go, oh, maybe we should use Kafka. Yes. So we can do that for them. If over time they want to open up real-time data exploration on their data, then we can do that via Druid and bring them into the real-time world at the same time, because it's just got lots of engines. Hugh. There you go.
Hello. So we've heard a lot about what Druid is and what it can do, and now I'm going to show you some stuff. So let me just switch over to my notes, if that's going to... There we go, great. Cool. So, hi, I'm Hugh. I've just joined the Implied team as a Druid advocate like 4 months ago. So I am like brand new to Druid. I've worked in data engineering, actually for Sainsbury's down the road, doing stuff for Kafka for a few years now, but never on Druid, so I've been learning a lot. When I got started, I wanted to build something, right? Like, I've done all the courses. We have some great courses. You should check them out. I did all the courses, but I like to build things to learn them. So I wanted to deploy Druid and have a mess around with it and figure out what makes it tick. So I'm going to talk a little bit about that. Druid has a shared nothing microservice architecture. So it's a bunch of different services all talking to each other that supports this, scatter, gather, fan out model. When you first start thinking about that, you're like, oh, that's going to be annoying to deploy. You've got all these different bits. They're all unique. How do I scale them appropriately? That can be confusing, but there are ways of making it easier. I used the Docker Compose from the Apache Druid repo. It's an open source project. People have done some of the work for you, so you can go and grab a Docker Compose and just run that. And it will get you started without having to go through some of that hassle. There's other approaches as well if you're not into Docker. There's a quick start script that just runs everything as Java processes. After all, Druid is just a bunch of Java processes running microservices. Peter tends to use that because he doesn't like virtualization. But personally, I took the Docker Compose.
This should have lights. That's what I believe, anyway.
So I'm going to show you how quickly you can get started with Docker, give you a quick tour of the web console, and then we can move on to talking a bit about ingestion. Look out for some of the services as well in there, like the coordinator and the broker, which offer up the main APIs, and the historicals and build manager that actually handle things like ingestion and queries. So if I jump over to here, I'm going to pivot now. That's the new thing I'm trying. Where is my terminal gone? Come on, Mac. Please hold. There we go. Something else like that. Right. Can anyone actually read that? Why is that? Hello? Why is that blank now? Huh. Okay. But all I'm doing here is running a quick Docker Compose, and you'll see each of those services come up. The text is in blank now. It wasn't before. Don't know why. Demo curse. But we have now started all of the microservices within Druid as quickly as that. So just by taking the existing Docker Compose image and running it, I have actually added Grafana as well, because I'm going to show you how you do some visualizations later. But it's pretty much as standard. Then I'm going to come back over. You can see everything now running in Docker. I'm going to come back over to my browser and open up Druid.
Can we zoom in?
Can I zoom in? Yes, I can. Also, sorry, look, that is in fun dark mode. Everything else is in light mode and legible, but we got a color scheme and we stuck to it with Druid. So you can see in here everything you need to get started with Druid. We've got an interactive query tool where you can write stuff in fairly standard MySQL to query your data sources, a wizard for loading data from streaming and batch, a view of all the data sources you already have loaded, the supervisors that look after all of your processes for ingestion, the actual tasks themselves for doing things like ingestions and long-running queries, segments, which are the aforementioned tiny databases that should store all your data. And if we jump over to services, we can see all the bits that actually make up our cluster. Cool, so we got Druid running pretty quickly. That wasn't too bad. Let's have a quick look at actually doing ingestion from a stream. So I did a talk about this in Berlin recently, but some colleagues and I have been working on a project led up by Helmar, who is one of our awesome colleagues in Germany, where we are using Raspberry Pis with antennas to collect data from aircraft, which has been pretty fun. Aircraft, if you don't know, all broadcast their location and a bunch of other information about them in the kind of radio frequency. And if you have a small off-the-shelf antenna, you can actually listen into that and collect that data, which is fun if for some bizarre reason you need a bunch of real-time data to demo a real-time database. I mean, it happens, I'm sure. So we have all of that data being collected on these Raspberry Pis and being pushed into Kafka on Confluent Cloud. Thank you, Confluent. And now we can actually ingest that data into Druid and start doing some cool stuff with it. And that's what I looked into when I was first learning. So now if I go to load data, I can open up my wizard for streaming. I'm going to continue from a previous spec. This is going to let me cheat on the first step, which is going to let me load in my config. But Kafka people will recognize immediately all that's in there is your Bootstrap server, the topic we're ingesting from, and the auth, which I can show you. And right away, Druid will sample from the beginning of that topic and let you know what kind of data to expect. I'm going to zoom through the rest of the wizard, but keep an eye out for some of the stuff that Peter mentioned, like filtering and transforming. And also there's some, oh, hello.
Does that create the schema?
Yes. So your schema, as Peter mentioned, is at the segment level, but the headings coming in from Kafka are what then are going to create the schema, or the column headings when I hit pass. So it will bring in just a second, the actual JSON from Kafka and turn it into a tabular format. So this isn't the full ingestion yet, though. This is just a preview. So now I'm going to zoom through the rest of the wizard, which is just finding our time column and giving us a bunch of options for filtering. I don't actually want to do that transform. This is cached from earlier. Narrow found is fine. Cool. And now that has done the task of creating this native JSON for us, which we can then send to Druid, and Druid will use to go to our Kafka topic and ingest all that data in the format we want. So now if I hit submit, the supervisor starts up. So initially it'll be pending, but then it will create all of the tasks for ingestion, and then it will run. And then under our tasks view, we can see right at the top the consumer that's now running, reading from that real-time data. Now we're reading from the beginning of the topic, which has a 7-day retention period. I'm sure someone mentioned that. And is now ingesting all of that into Druid. Once it catches up, in the sense that it's ingested all of the 7 days, will be at real time. So as soon as something appears in the Kafka topic, it's within Druid very, very quickly. The limitation being like, yeah, your internet there, I guess. And then we can now query this real-time data as it comes in. And I'm just going to query everything we've got for the time being. And we can see all of the data that we've got coming from Kafka with the Kafka headers for each of those columns. So ingesting from Kafka is super easy, particularly if you already know what you're doing with Kafka. It's pretty simple. Having the data in Kafka, having the data in Druid is all well and good, but now we actually want to start working with our real-time data to find insights and take a look at it and actually do stuff. So inside my Docker Compose, I actually already have Grafana set up, and I can start hooking Grafana up to Druid to start building some visualizations and kind of exploring my data a bit. So if I jump over to Grafana, I'm going to jump over to home. So if you want to connect a visualization tool or a dashboarding tool like Grafana to Druid, it's actually really easy. Druid, being an open source project, has a bunch of really good support. Man, it's just very small, hard to see. Cool, so there are plugins for a bunch of different stuff in Grafana, and there is one for Druid, which you can get very easily from within this view inside a deploy Grafana instance, or you can pre-provision it like I've done with the whole kind of here's one I've made earlier feeling. The data source is also pre-populated, but it's super simple. You can just go to add data source and add it. And what we're passing in here, the only argument, because I've not got auth set up on my Druid, because it's just for the demo, is the URL of the router, which is the service which is responsible for directing API requests and queries to the correct service within the Druid cluster. So once we're all set up, we can build dashboards really easily by running the same SQL queries that we run in the Druid view in Grafana to get the tabular data back, and then passing that onto Grafana to do visualizations with it. So for example, we can grab all of the data that we're getting from the 2 receivers that are live at the moment, which is Peters in Cambridge and Helmar in Germany. And if we zoom in, we can see each of these crosses is the position of an aircraft when we received a message from it. So this is, you know, it's a pretty fun visualization, but there's not a huge amount going on here just yet. And you'll notice that like the performance is not amazing. Like there are lots and lots of points, and Grafana is not loving the fact that we're like, oh yeah, plot like 30,000 X's on this map right now. A bunch of the data that we're getting is very tightly grouped. So sometimes you'll have like 30 messages from the same aircraft in like a second, which is like, you know, it's great that we can get that in real time and we can query it very fast on Druid, but Grafana is not loving that. Like that's a lot of data all at once to plot. And also a lot of the data we get from these aircraft has like null values because there's a bunch of different types of messages and each of those messages will contain a certain data point. So there's a bunch of clever stuff we can do to clean that up in Druid, and we're going to take a look at that now. Obviously we've seen now how you can get real-time data into Druid, but if you want to get older data, for example, for reporting, or if you have data from somewhere else, you can ingest it via batch. And when we do our batch ingestion, we're also going to take a look at some of the things you can do with regards to aggregation, grouping by time intervals, and removing some of these big sections of null values, and hopefully getting to a point where Grafana isn't screaming because we've given it 50,000 points to plot in 2 seconds. So to do a batch ingestion, we're going to jump back over to the Druid web console. I'm going to stop my real-time ingestion task. You can run real-time ingestion and batch ingestion at the same time. There's no reason why you can't. It's completely supported. But I'm running this with like 2 gig of memory because I'm lazy. So I'm going to terminate this process, mostly because I want Chrome to run fast. And then I'm going to go back to load data. I'm going to use MSQ to ingest from batch. And again, you can see all of the sources that Peter mentioned as places you can ingest from. Being able to ingest from S3 directly is super sweet because it's nice and cheap, right? And I'm going to ingest directly from GitHub because I have a sample data file zipped there. From the same GitHub, all of the sample code is for the whole aircraft demo, actually. So if you want to check that out, that's where you want to go. I'm going to jump over to HTTPS. I'm going to upload my URL. And as before, Druid grabs the data, finds the JSON, and then pulls it into a tabular format and detects all the headings right away. I am going to change this up a little bit because I want to put the data in as backfill. So I have 7 days of data, and I want to put this data in as the 8 days ago to go directly before that gap. So I could just hit next now and ingest this, but I'm actually going to change the data a bit. So I'm going to go directly to SQL. And you'll see in Peter's point here, we're not creating a new table, we're replacing into an existing table. So I am going to grab some SQL from down here. 2 seconds. The demo magic is I'm copying and pasting from a document you can't see, so bear with me. There we go. Right, and I'm going to replace that. Cool. So this is very similar to the ingestion we were doing before from real time, but obviously instead we're ingesting from a file rather than from a stream. But what we're also doing here is, aside from changing the timestamp to be 8 days ago instead of the original date, is reducing the number of columns we're ingesting. So there's all of the same data as there before. There's like 16 different data points that you get from this data. But as this is historic data, maybe we aren't interested in whether or not there was an emergency. You know, like if a plane safely landed 2 weeks ago, do we care if there was an emergency alert? So right now we're just getting down to things like a longitude and latitude, so we can plot the historic routes and measuring things like the speed. We're also aggregating at 15-second intervals. So on ingestion, what Druid will do is take all of the records in that 15-second period and roll them up together. We are using all of these different aggregations, so the maximum value for numerical values and just pulling in the string for everything else to squish all those 15 seconds together. And the count field we have there as readings will show us like how many we've been aggregated. This is going to do two things for us that's great. One of them is it'll give Grafana a break because it won't be like 50,000 records, it'll be like significantly fewer. And it will remove a lot of the null columns that we're not interested in, and we can just focus on the data that's actually useful. And it's going to speed up our queries because we're querying significantly less data and significantly fewer rows. So now if I run that batch ingestion, give it 2 seconds. So the middle manager will get the query and we'll open a task for running that ingestion. Why? Oh, I forgot to change the dates. Hang on 2 seconds. So I am overwriting a specific date that is a week ago. So that needs to be a week ago, 7 days. Let's run that. Cool. Roughly a week ago. My maths isn't quite that bad. So the batch ingestion will run, and all of the records in that file have now been ingested into Druid. So we can jump back over to Grafana. What you'll also notice as well for people who are used to things like schema stores and changes to the schema being a real pain, we have removed a bunch of columns here and we've ingested into the same table, but the schema doesn't need to be the same because it's going into a different segment because we're partitioning by time. So this is going into a completely separate file. So our changes to the schema and the changes to the names of the column doesn't blow everything up. It can be completely separate. And we can see that if we jump back over to Grafana, that everything still works. We can refresh our query and we can look at the last 30 days or 7 weeks or include that newly ingested data and everything works fine. So there you go. We have taken a look at, and Grafana does not love plotting all those points. No noise on Grafana, I'm just using it wrong. But we've seen now, like, it's super easy to get started with Druid if you fancy experimenting with it. You can ingest data really easily from Kafka using the same kind of processes you use for anything else. You just plug in your values and you're good. And it's super easy to provision that with whatever IAC tool you're using. You can build visualizations on top. Grafana is great, I love it. But you can use Superset or Tableau or whatever works for you as connectors for Druid. And batch ingestion will let you do backfill. And obviously the joy of Druid being that you can have all of this historic data ingested for reporting, and you can have your real time at the same time, and you don't have to deploy a bunch of different things in parallel. So yeah, that is all from me. Do you want me to cover call to action? Or
No, should we do questions?
Yeah, sure. Thank you very much. Okay. Cool.
Yes.
Can you talk a bit about what a productionized deployment looks like? So scalability, performance, availability, security.
Do you want to bring the services tab up?
Yep.
Okay, so being really specific, there are a number of processes on here where you can have, let's say you have an odd number in production, because there are leadership elections that happen between them, right? So we've got the overlord, the middle manager, the coordinator. No, sorry, that's wrong. The coordinator, the overlord, the router, and the broker. Those processes in a big environment, like a big production environment, you've got 1,000 of these bloody things running. You've got an odd number of those, and the leadership election happens between them. So when you're doing upgrades, for example, all of that leader election is automatic. It means you can take them down and bring them back up and do running upgrades, right? The historicals and the middle managers these are in charge of ingestion, these are in charge of querying. So in a production environment, you need to, and this is why imply exists, because of our fantastic expertise in scaling this wonderful database. You need to work out what your query patterns are going to be and how much data you're going to query, and that's how many of these historicals you start spinning up. In a startup environment, each historical has 300 gig. At a particular search engine based company, these could be a terabyte, right? It really depends on your query patterns, it depends on your data partitioning, etc., etc. But historicals are where you would have multiples of these based on the amount of data you've ingested, right? How big your tables are and what your replication factor is. And then the middle managers are providing the ingestion resources, number one. So every time when Hugh created a task and it created this task process, that's a consumer. A consumer is consuming from one to a number of Kafka partitions. So you need to think, how many partitions have I got? What's the throughput on those peons, those tasks, those consumers? Okay, that's how many CPUs I need in total. Okay, now how do I break that CPU requirement up amongst enough middle managers to give me enough resilience? That's how you scale a Druid cluster.
Do you have some diagrams on your website?
Absolutely do.
Yeah, okay.
Unfortunately, you'll have to listen to me again. But if you go to learn.imply.io, there's a Druid Basics course on there. Scaling is much easier now than it used to be, because there are things like, there's a script called the start Druid script, and you literally run it. It's a bit of Perl, and it just goes, how many resources should I have for what processes I want to run, and it just goes and scopes the whole thing for you.
Aside from pure scalability, how do you deal with availability? So things falling over, HA, DR.
So the data, when it's, so these historicals, as I mentioned, like you've got this prefetch operation that happens for these really, really fast queries, right? So you've got consumers being queried directly. Every so often they're persisting, then they're being prefetched into these historical processes. There is a replication factor for those historicals. So in open source, the default replication factor is 2, but you might have 3, 4, whatever you can pay for, basically. And then on the middle managers, you have exactly one suggestion guarantees on the consumers. So if the consumer just goes, or Kafka goes, then it doesn't update the topic offset until it knows it's definitely been ingested. That's number one. But secondly, you can also replicate the actual individual consumers as well. So you can have middle managers over in France, middle managers running over in, name another country, Bolivia, and as long as France doesn't blow up, essentially those two consumers can be running in different places. You are kind of in really highly important consumer situations. And also that increases parallelism, by the way, of the query execution engine.
Okay. And when your customers are asking about security of potentially sensitive data,
yes,
what do you suggest as the right way?
So Druid, open source Druid. My boss is going to like that I keep saying open source.
Really my next question is similar to with Kafka and how you can do it in multiple ways,
Yes.
self-hosting to Confluent and other managed service. What is the differentiation between pure open source Druid and the Imply stack, and then hosting with Imply or self-hosting yourself?
That I would like to direct towards the sales team, who will be at the back of the room for questions later.
Okay.
But essentially in open source, there is enough security for you to do your kind of grant kind of SQL operations to a table. There's integration with different authentication providers, being specific. And then that is where, when you want to do like, oh my God, row level security or column filtering, all those kind of things, that's where you then end up in the kind of realm of other options.
Okay.
Yeah. Yes.
Finding slow queries or stuff like that.
Sorry, say that again.
How would you go about finding slow queries or
Okay.
problems?
So there are a ton of metrics that get emitted by Druid, right? And now my experience when I joined at Imply, I was an SE and I earned a lot more money. But there was there's some key metrics in terms of query performance. So yeah, we've got the parallelization. So if you guys know what parallelization is like, there is a certain set of metrics and things you look at with parallelization, right? But at Druid, one of the key ones is about the segment scan time, which is essentially a really key metric on throughput. Like, how many rows am I scanning? And once you know that, there's unlocks in terms of, well, should I have parallelized in a particular way? Should I have used aggregation in a particular way? Should I have partitioned or sub-partitioned in a particular way? And those kind of things are all like, there's docs that explain all of that. But for me, my first protocol when it comes to performance is that level of what metrics are telling me what. And so slow query performance is very much open in the metrics that Druid emits. So there are people in open source who are using, like, they're putting their logs into Splunk, they're putting their, into Elasticsearch, they're putting their, like, stats into Elk, not into Elk, bloody hell, through to Grafana. Right, they are monitoring Druid. In fact, like, there is a course on learnedimply.io, which is about monitoring. But genuinely, when I say in that course, go and set up your metrics, I like really mean it. Like, go and do it. You know, go and observe the children. And also there are best practices. Yes, sorry, yes.
So just had a quick question. Does that make the middle manager stateless? Like, which of these components then are stateless?
Oh, they're all stateless.
They're all stateless?
Yeah. They don't communicate. Well, there are APIs between them. So, for example, when you kick off a query execution, when you say submit a ingestion job, it goes into a queue, and these middle managers are advertising how many slots they have available. So here it says slots 0 of 2. We've configured in this environment that the middle manager has 2 slots, 2 worker slots available. And then there is a queue of, hey, the overlord needs this to happen. It goes off to Zookeeper at the moment. And then the middle manager picks up those tasks and goes, I'm going to work on these. And then eventually, and it's publishing via its APIs the status of all the work that's going on. So there's no like tight coupling between them. And that does mean like you can spin up a middle manager in the middle of the day because you're bored, and Druid will go, oh, I've got 3 more slots. I'm going to do a massive backfill. Okay, I'll add some more middle managers. And then when you're bored with it, you then take them away again. This category thing here is used when you want to assign particular types of ingestion or processing work to specific middle managers in a group of middle managers. But do you know, like, this is just because it's a good architecture. Does that make sense? This is just a good architecture where they've gone, oh, how should we use this architecture to run a database? Oh, okay, then we'll do it like this.
So,
like they did with Kafka, to be fair.
So I only need to care about each historical node I've got just for the disk node to fill up.
Yeah, exactly. Well, so there's another mechanism behind that we can talk about that. With the historicals, when you want to expand because your table's gotten bigger, you just add more of them, and it will distribute and shuffle them. If one of these dies, it continues to run, the queries continue to be executable, and it's distributing the data.
So is the historical analogy to Ceph where it just goes around and shuffles it around?
Yeah, and the thing that's doing that, actually, the coordinator is the thing that's keeping an eye on the state of the cluster. Like, it's the thing that's keeping the last known good configuration in memory. Yeah. Let's think about that then. And then making sure the cluster's healthy. Yeah.
How do you do workload management, like quotas, resource pools? If you have different groups of users, multi-tenant environment and stuff.
Yes.
So how would you manage that?
So there are lots of different options. So one really obvious one is a thing called query laning, query prioritization. So essentially you can tag a query with a particular query priority, and it will jump to the queue of any other queries that are running. But that's just one way of doing it. Another way of doing it is at the data distribution level. So if I was to say to you that these segment files that are being pushed to the historicals, we can say this age or this table, I want you to go to that set of historicals, right? So you can manage where the queries get executed, like what resources are actually utilized, by putting the relevant data in the right place, okay? Now, when I'm saying exabyte scale, when you're like at that massive level of scale, there is a set of stuff that you can do in the broker, which is a lot more complicated, that was written not by me. It was written by other companies that enable you to divvy up the work even further than that. And when it comes to multi-tenancy, there is a docs page on multi-tenancy, and generally speaking, in multi-tenant environments, it's like, decide, do you want several different tables, or do you want to sub-partition within those tables? But we can have a chat about that afterwards.
I think we're well over time.
We are, aren't we?